The sponsorship that I've got on my channel for some of the videos from PCBWay has been something that I really have treasured, and it's allowed me to do something that I'm sure a lot of hobbyists would like to do, and that is to experiment, to actually try prototypes. And if you've done this sort of thing, you know that getting it right the first time can be a challenge. I am no different, and this project is no different. This was the Selenium Bridge Rectifier and Diode Cap boards, which I designed and ordered some time back, and I've used quite often. It came with some things that I would have liked to change. Let me show you. First of all, I got a heck of a lot of them, which was a mistake. And the reason is I designed them so that they were 3 to a board. And before we carry on, I just want to draw your attention to their website, PCBWay.com. This is where I come and get my boards from. And they've gone way beyond just doing PCBs, because if you come on here, you can get CNC printing and 3D printing. I know other people who've done it, very happy with the result. Here on the Products and Capabilities tab, you'll see just how far they've gone in terms of what it is they can do for you. And the other thing that's really important, if you get confused, is you come to their chat support. And during the week, this chat support is manned by someone, and you can get onto them, get their help. It really does make a difference, because sometimes this gets a bit confusing. You know, there's so much stuff to ask about and to inquire about. You might just have a question, and in this case, they will give you the answers right away. In this particular case, I'm doing this on the weekend. You can see the times here. It's closed at the moment, but it works very, very well. So whatever you want, whether you want standard PCBs or advanced or rigid, or if you want to do CNC or 3D printing, pop over to them. It's so simple. You put in your CAD file, you put in your characteristics, and they give you a price. Boom. It's fantastic. Enjoy. Let's carry on with the video. There's actually some logic in that. The pricing that they give you, and you can get that on their on the website. You put in the details of the board, or you just upload the Gerber files. They give you an instantaneous quote, is for a maximum of 100 millimeters by 100 millimeter boards. So the idea of creating a board which is, you know, that size, so something like that, was not the sort of thing that I wanted to do, because I'm pretty thrifty. So I decided to do 3 on a board, and that was actually a mistake, because first of all, these boards don't work out at the minimum price, as they are complex cuts, as you'll find out if you do a simulation. But it did work out pretty well, because when you get say 10 of these, and there's 3 per board, you get 30. In my case, as I said, that was a mistake, because I ended up with things that I wanted to change, and I've been reluctant to change them because I've been trying to use up my stock, and I don't like throwing things away. So that's the reason why I've left it till now. But here's a typical one that I've used often enough, and you might have seen it. You might have seen me use them before. What are these things? The idea of this is to replace the Selenium Rectifier. Now, this thing's got 4 diodes, 3 resistors, AC in, and it's got a plus and a minus there. The idea is that you replace one of those Selenium rectifiers, you know, the rectangular ones. I think a lot of them are Siemens. And you would take that out, and these holes, these 2 holes over here, fit exactly where these screws go through that rectifier. So we could just remove that rectifier, change the wiring, and in fact, on that rectifier, the positions of the 4 connectors is precisely on these opposite ends. So you'd replace this, fit this in where the other one was, and you'd have a replacement. And as I've mentioned when I did this project, the idea of these resistors is that because you have a bigger diode drop on the Selenium Rectifier than you would have on 4 silicon diodes, you may want to drop the voltage. The B+ coming out of this thing could be too high. And so you put a resistor in series, and I'll show you the schematic in a second. It's very, very simple. You put a resistor in series, you would try it out. If you want to drop the resistance, you put another one in parallel with that one. When I say in series, I mean in series between the output from the diodes and the positive terminal, which is effectively your new B+. So you can add resistors to get the right value to give you the right voltage at the B+. This thing worked out very well, and then I decided to do these, which is, you only use one of them. You replace your capacitor, your filter capacitor. This would go on the underside. You would put 2 capacitors on here, because those filter caps are normally duals. You would have connectors for, and I think you can see that, C2, C1, there's 2 connector pins on there, or holes on there. And C1 would have 2, C2 will have 2. So you wire whatever's wired to those capacitors to the same point here. And the ground lug is a common ground, just like those filter capacitors. And this ground lug would then fit into one of the protruding pins, or whatever you want to call them, which holds the capacitor in place. That's worked fine. However, I did notice some mistakes, which is what I've wanted to correct now. And you can see that if you look at this as it is, the first thing that comes to mind is the size of these capacitors. You do get capacitors of this size. This is 10 millimeters. And I will show you, you do get capacitors that are 10 millimeters in diameter. They're normally very tall, and they are 47 microfarads at 450 volts. But most of the ones that I've used are actually these, which are about 12 to 13 millimeters, and they're slightly too big. So when you put that in here, as you can see, they go over the edge. They actually infringe on the space for the second capacitor. So I have used this before. I bend this slightly, but then what happens is when I do this, I then have a problem soldering because these solder tags down there are very close to the body of the cap. So it becomes a challenge, and I wanted to correct that. The other problem is that some of these solder pins are very, very small. If you look on the underside, these are the standard ones that most of this PCB software will give you. So what I normally do is what I do on this side. For example, for these diodes, I've made the pins a little bit bigger. They're still not big enough in my opinion. These solder pins here, these holes, are also not big enough in my opinion. I wanted them bigger, makes it easier. These big resistors, I widen that to 3 millimeter with a 1 millimeter hole so that I can solder them easy. Again, I would have liked them a little bit bigger. And all this I would have liked is something that I decided to correct now. And I'm going to show you what I've done differently. One other thing is, in the last restoration that I did of the Scandia, the Nordmender Scandia, instead of having one of this shape of Selenium Rectifier, they had this guy. And fitting this to the space where this thing came out was a bit of a challenge because it got these contacts a little bit closer to some other parts of the radio that I would have preferred to move away. So I decided to do one that's smaller than this. So what am I going to use? A big one or a small one? Well, I decided to do both. I'll show you, I've done both. I've redone this one, and I've not added a second bulb at the end. That's useless, okay? I've just used one, and I've made the changes that I just described here. And then I did one that is smaller so that I can't make it this shape, but I can definitely make it quite a bit smaller. So whatever space this is taking up, this smaller one would probably fit in. And that's something that I've definitely needed in the past when the Selenium Rectifier is not that standard size. Let me show you what I'm talking about on the screen. Let's start off by looking for those capacitors, just to make sure that we can get some good quality capacitors in the sizes that I'm talking about. I'm on Mauser, which most of you probably are aware of. I'm looking for aluminium electrolytic and radial. It's radial, okay. I'm looking for 47 microfarads. That's usually what we want. They're normally quoted as 50 microfarad caps. And I want 450 volts. Well, here there are a few. So I'll just go from, let's try 420 and 450. And let's look for the results. Here we are. We've got 105 of them. Well, let's make it the 105s. Redefine that, make 105 degrees. Okay. Now, we've still got 93. Now look at this. This is the diameter, 10 millimeters, 12.5, 14.5. So I can use either one of these on that thing with no problem. I could probably fit 14.5, but that's what I'm looking for. And what do we have? Well, if we look at those characteristics, we've got some from Rubicon. Nothing wrong with that. Those are very, very good capacitors. $2 or €2.95 each. You can buy them in unit prices. You don't have to buy bulk. There's United Chemicon, Rubicon, United Chemicon, Nichicon. Nichicon is here. That's the 12.5 millimeter. So we've got Nichicons. Again, very, very, very good capacitors. There are quite a few Nichicons. Now, Nichicon, I seem to see... No, these are... Here we go. Nichicon 10 There we go. Nichicon here, 10 millimeters, 450 volts, 105 degrees, 5 millimeter spacing. This is 5 millimeter high, 50 millimeter high. So they stand up pretty tall. This is just to show you that you can get these capacitors. People think that 47 microfarad capacitors at 450 volt have got to be these big, thick, bulky bits. Now, regardless of whether you're using my system or whether you want to restuff those caps, getting this size of capacitor, 12.5 or 10 millimeters, is actually useful even if you want to restuff. Here's a 10 millimeter from United Chemicon. If you want to restuff them, this works perfectly because they fit nicely into those cans. So here we go. We can find these caps. Now, what is the new board going to look like? I'll start by showing you what the old board looked like. If you recall, I had the diode, the Selenium Rectifier board, and 2 of those filter capacitor circles. And to get that done on the PCB, this is what it looked like. Diodes are just, I use 4007s because they just work well. They're a good range. They're 1000 volts up to, I think it's 1 amp. We never need that. So those are my go-to diodes. And here are my 3 resistors in parallel, in series, or in line with the B+ output and the connection or the solder tag for the positive. We have the AC in, and the negative there. No mystery there. And then this is the capacitor layout, 2 capacitors, 47 microfarads in with a common ground. There's a ground tag, and then I've got C1, C1, C2, C2. Okay, and I've done 2 of them because I want this to be duplicated when I build the PCB. And the PCB then looked like this. This is exactly what I've just shown you. And when you look at it on the board like this, it actually looks big enough. You know, this tag here, you'd think is big enough, but it's actually quite small. It's small when you see the result in your board and you're trying to solder to it, and it's just not something I like. I've done these bigger. These guys over here are bigger. You can do them separately depending on what software you're using, and I'm not advocating any particular software, but you can change the component as a whole, or you can actually go to the board and change each of those pads separately. You can make them square, oval, whatever you want. So I normally make my components, I redesign the footprint so that the components have a more comfortable solder pads. And there's the holes for the mounting, and you would do that with a standoff. Anyway, this was a good idea, and I had 3 of these together, and I sent this for fabrication. And I did find that when the quotes come in, they were slightly or quite a bit higher than I expected. But this is what I wanted to change, and I've done it. And here is the new board. Now, I have not changed that much, as you can see. What I've done is this board here, this small board here, is exactly the same size as the previous one. I've done a little bit of shifting to the left here on these 3 resistors because the diodes, I wanted to give them a little bit more space between their legs. The other ones, you had to really bend close to the diode itself, almost force it. So instead of having 8 millimeters or something, I think what I've got here is about 10 millimeters, if I'm not mistaken. I've got these slightly more comfortable to fit in, so they had to fit in sideways. Everything else is the same. Our AC connectors are bigger. They're also on the opposite ends as they were before. Here's our positive terminal, here's our negative terminal. No mystery there. What I've done here is I've made these bigger. This is now 12.7 millimeters, and that means I can use either the 10 millimeter, 12.5, possibly even the 14 if I shift them slightly, but I've got now 2 options of capacitors that I can use here. I've made this circle diameter a little bit bigger. It might be a little bit more difficult to fit it on the underside of some of these smaller capacitors, but if if I can't, then I'll probably just restuff those caps. But this becomes a lot more comfortable. This ground tag with a hole in the middle is bigger as well, and these are especially bigger and closer to the edge, because once you've got the capacitor fitted in here, you can more comfortably solder to the tags over there, to the poles over there. And we can see this in 3D as well. This is what this looks like in 3D. As you can see, you've got nice access to the capacitor connectors there, the big round. This is a 12.5 or 12.7 millimeter capacitor diameter. Just as a demonstration, this is what these will look like. And everything is nice and neat. And you just break that connector there. Those holes make it easier to snap that off. And this is your new board. And that's what I'm going to order. I'm going to order these boards. I'm going to order them separately. I'm not going to put 3 on one, because if I order 10 of them, I mean, 10 of these things, it'll take quite a while to use them all, because not all radios that I get require these particular little boards. So if you want to order them, you can, I'll put the link in the description of the video to PCBWay's website. It's the share section of that, and you can just order them direct, and they give you an instant quote and all that stuff. I'm sure you're accustomed to that method of ordering your boards. Now, what did I do for the smaller version? Let me show you. For the smaller version, I've got the same system. There is a difference. I've added the negative. I've added 2 pads, and you'll see why in a minute. 2 pads, and I've only got 1 resistor on there. Now that means that to actually change the resistance, you may have to fit and remove resistors till you get the right one. We don't have the comfort of being able to put resistors in parallel. Of course you can solder one on top of the other, but it's a little bit less user-friendly. But that's the idea. You've got less space, so you've got to be a little bit more careful with choosing the resistor. You can always use like a decade resistor box, another project I did very recently, and get the right resistor and then use the closest standard value that you can find to that, and you'll have one shot at it. But this thing looks like this as a board. And as you can see, same story, but I've made the layout slightly different. I've got 2 holes on here to mount this. You've got to mount this somehow, and I didn't want to put holes anywhere in the middle. These diodes are the same as the first version, so the diodes are slightly smaller in terms of pitch between pins, but the holes are bigger. These holes are actually bigger than the original. And then the way I've done it is I've made these connectors, these terminals, exactly the same as what you find on that little Selenium rectifier that I showed you at the beginning that I'm replacing. They have positive in the middle. They've got AC in, and then negative. The 2 external ones are negative. They're common negative. So I've made those 2 accessible. That's why I put 2 of the tags there on the schematic. This is exactly the same. These will even be smaller when you order them, if you order them. But again, if you order 5 or 10, they'll last you quite a long time. And in 3D, this is what this thing looks like. It's pretty neat. This distance from there to there is slightly bigger than the depth of the one that I'm replacing. But remember, this one that I'm replacing is not standard. It's not the same in every case. Some of these Selenium rectifiers in later radios were looking different. They were looking smaller, but they were different. They weren't all the same. Recently, I saw another one that was very similar to that. I think it was that SABA. I think that SABA had a similar rectifier, this shape that I've just shown you. And so this would have been a perfect one to replace that with. But again, this part here is exactly the same. There we go. And this one here, you would snap there as well, and you would have access to these solder pins. Very nice and neat. All the underside needs to be insulated, because remember, on this underside, you've got AC, high voltage AC coming in there and there. So you'll have wires coming through and you solder them. You can solder them from the underside as well, but nevertheless, you've got high voltages, and then you've got the B plus as well. So when you put this against a chassis, you've got to make sure that the standoffs do not allow any of this to touch the chassis, or you're going to have a very bad day. Same applies to that. You connect this to the ground lug and you raise it above the other any pins that are, or any wires that are in the vicinity. And what I generally do is I put one of those pads, you know, those foam pads, insulated foam pads, just to make sure that this never touches that chassis. If it does, it's going to short and your fuse will blow, if not something worse. So here we are. These guys are ready to be ordered. I'm going to order them. I'm going to put the link for the PCBs on in the description. It'll be from the share section of the PCBs. It might actually take a day or two for me to add that on, because I'm going to order these now. And when I receive them, I probably won't even tell you, because unless something is wrong, and then I'll just warn you not to order them. But if it's wrong, it'll be my fault. It won't be the PCBWay's fault. This thing is great. I love this. I love the opportunity to be able to play with these things and experiment, because sometimes, or actually very often, you just don't get it right the first time. So it's always nice to have the freedom to experiment and try again. So I hope you've got something out of this. I hope this is one step further, one step closer to making it simpler to do some of the restoration steps on those radios. Restuffing filter caps is not something a lot of people enjoy. I often do it, but I'm tending more towards doing this sort of thing rather than restuffing, because it is really a messy job, and it doesn't always come out as well as David Tipton manages to do. We're not all Tiptons. So us mere mortals just do our best with something like this. Anyway, once again, thanks for watching. I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal, links in the description below. Thanks for watching, bye for now, and most of all, stay safe.